Okay, welcome to Object-Oriented Programming, and today is the 6th practicals. I think I'm loud enough. Is it also true for you? Yes. What's today's content?
So today's content will first have a recap quiz about our exceptions and then talk about operator overloading and iterators.
Yeah, and I'm really looking forward to teach about iterators. I think this is one of the most interesting topics. So stay tuned, please. Organizational matters, it's not that much today. We have a question hour for assignment 2 in about 2 weeks on Monday. In the evening, I think you have data management before, and then afterwards we do the question hour. So it will be on campus, and we can help you as a group, and there will be several tutors there. And just remember the deadline of assignment 2 is then 1 week later at the 22nd of May. And we also would like to give you a short outlook what happens in the next lectures. So next time there is Christi Himmelfahrt, so we have no lecture. The week afterwards we will talk about smart pointers, and we will also continue the topic of iterators. And then 1 week afterwards it gets really interesting because that's our favorite lecture, because we teach you then some selected topics that we think are the most interesting ones in C++. And this is of course not relevant for an exam or for the practicals, but it's hopefully very interesting to you, and maybe you find something there that you enjoy and that you can also use in your assignment or later in your programming career. Okay, then the exception quiz. We have prepared the Slido, so you can already join, I think. Okay, yeah, it's working. How many are we today? 40? 50? Okay, do we start at 30?
I think that's enough.
Oh, yeah.
I think they can still join. So let's get to the first question. I think you already did similar ones last week in the lecture. So this is just, some exception classes, and then we throw one of them. And now the question is, what are we printing? So which catch clause is executed, or multiple?
So really have every possibility here as an answer. Do we see the code if we go to the answers?
I hope so.
Otherwise I have it.
Okay, so let's see the results. Okay, so that's the results, and the correct answer is A. We still see the code. So what actually happens here is that the first catch clause, which matches our exception, is picked, and because the class B inherits from A, the first one matches, and so this one is executed. If we try to compile this, the compiler even warns us that the second catch clause with the reference to a B class can never be executed, because this exception would already be executed with A. Okay. So then continue with the next question.
It looks very similar to the first one.
It looks very similar, but the difference here is that both classes inherit privately. So B inherits privately from A and A privately from the exception.
I think also we were surprised.
Yes.
Waiting for 3 more people. 1 more. I think then. Yeah.
Okay, so let's look at the results. So it's a pretty even split between A, B, and the exception. Now let's look at the correct answer, and it's B. So this time, A is actually wrong, because in the C++ standard, it just states that the first catch clause is where the class matches or which inherits publicly from the class which is written in the catch clause is picked more or less. So yeah, it's just by definition that when you inherit privately from outside, you can't really tell that you even inherited.
So basically, it's not visible that B inherits from A outside of the class B. Yeah,
Okay.
and that was really tough, and we will never ask this at an exam, also with private here, because you would never use that, I think.
Okay, then let's continue with the next question. So I think this is a bit more easy. We're just creating a map. Again, I think we had a similar example when we introduced the map. Yes, and then we try to access this map at a key which is not in the map. And yes, we want to know what happens now. Okay, so most of you voted for out of range, which is actually the correct answer, because yeah, a map also throws an out of range exception if you access it out of bounds. The same as with the vector. Yeah, the map throws the same exception.
Maybe we say this here. We use here the add method, which you should use. If you would use here the brackets instead, then an empty entry would be created in the map, which is probably not what you wanted to have here. So please use the add at the map.
So if we would have used the square brackets instead of the add to access this map, then 0 would be the correct answer. So this is why you probably only want to use add.
Okay, should we reveal the leaderboard right now?
Yeah, let's check the leaderboard.
And Max won.
Congratulations.
But only 3 people completed all correctly. Okay. So it's good that we made the quiz and that you prepare for the exam then. Okay.
Yeah.
I think I need to continue. Okay, operator overloading. What do we do today? This will be our main example, and basically everything that we do today is based on this example. And some time ago, we wrote an array on the heap. So let's have a look on that. So we called it, I think, list in this example. Now we renamed it to vector, which has two private attributes. One is the length and one is the actual data. And the data is then allocated on the heap. And in particular, we talked about the copy constructor there, where we said, okay, we need to do a deep copy. Otherwise, we would have two lists or two vectors pointing to the same array. And we also implemented an add method, similar to the std vector that you know, and also some length method here. And last time, when we implemented this, in particular the add method here, we did some check whether we are in the range of the array. So for example, if we have a size of 10, then we would check, is our index between 0 and 9? And if this is the case, then we would have executed the index operation on the array. And otherwise, we did not know what to do, how to stop the program. And from now on, we know how to do this with an exception. So just as a short recap, how to throw an exception. I need to disable cheat mode. We can throw, for example, here out of range exception, index out of range. And we need to include the standard exception header that it works. And now our add method is completed. So this is the last thing that was missing. And now whenever we access our list, for example, at size, which has size 10, and we call list at position 11, and we run the whole thing, then we get a out of range exception. Okay, so this was just the last missing piece in our example from last time, and now we continue with the new stuff in the example. And the first thing will be the assignment operator that we've seen last time. And then we also implement an access operator with the square brackets. And we will also consider this array, this list, and as a mathematical vector so that we can implement operations like vector addition or a multiplication with an integer in our case. But the first thing is now the assignment operator. And maybe you can show us how we can implement this assignment operator.
Okay, I think we'll just start with implementing one. Yes, as you heard in the lecture last time, you need one whenever you also need the copy constructor. So let's do this. Oops. Okay. And what we need to do here is if we assign one vector to another, it normally would just, the default assignment operator would just copy the memory, which is the same problem as with the copy constructor. And we now need to copy over the whole memory from the other vector into the current vector. And also we shouldn't forget, because the current vector already exists, that we need to delete the memory of this current vector, which I'll start with. Yes, so I think we called it array. We need to delete the current array. Then we need to update our length because we just want to copy over everything from the other vector. And then we need to create a new one. Yes, with our new length. And then we just iterate over everything. And copy it over. Oops. And because the assignment operator also returns a reference to the object which was assigned to, we also need to return the reference to this. We already used this last time, and you already heard this in the lecture, that this just is a pointer to the current element, and then when we dereference it, we need to dereference it to return it as a reference. Okay, then
maybe we can go back to the definition of the assignment operator. Now there is a lot of vector, and vector in the function header. Why is that, and why do we return this reference?
Okay, does anyone have an idea why we're returning a reference in the assignment operator? Yes?
Because we later need to do something with it to actually make it work.
No, that's not the reason, because, yes?
So that we can concatenate methods.
Yes, so when we are assigning something like this, then in C and C++, we can do something like this and have like a third thing assigned. And in order for this to work, the assignment operation needs to return something which we then can again assign stuff to, and that's why we are returning this reference here.
So, and if we do now the most right assignment in your example, A equals B equals C, what are then the parameters? What is the parameter in this assignment operator, and what is?
Yes, so here we are calling the assignment operator on B. Maybe I'll just zoom in.
Yeah, I think so. It's better. Yeah.
Yeah, so we're calling the assignment operator on B, and the other vector here would be the C, and we are returning a new reference which would then get assigned to A.
And this new reference is what?
Yeah, it's just
B is after the update from C.
It's just B after we called the assignment operator. So that's the reason why we're returning the this. Yes, so maybe let's go over why we need this. So just the theoretical part. We said that we need to implement the copy constructor whenever we want to do something differently when we are creating a class based on something, some other class. If we have, for example, our array here, if we want to copy it, like when we're calling the constructor and creating it the first time, and we pass another class, the default behavior would just copy over the pointers, and we would have two classes pointing to the same array. This is not what we want, because when we copy something, we basically always want to also copy all of its memories and don't want to have any shared references. And that's why we implement an explicit copy constructor or delete it.
So in the default case, we would really have this shallow copy that we talked about, where only the pointer is copied and no memory behind, and we really need this deep copy, that new memory is allocated and that the content is copied and not only the pointer.
Okay, and now let's get to the assignment operator, because here we have the same issues. If you would assign something to our vector class and just copy the memory, then we would just copy the pointers, which are in this vector, and then we would again have two vector objects pointing to the same array on the heap. But we don't want that. We want to always create a new array on the heap, so that if we modify one, it's just this one that's modified. And the same is with the copy constructor. The default assignment operator just does a shallow copy, but we won't need a deep copy. And again, the solution is writing an explicit one or deleting it. And maybe down here there's a bullet point that we need to consider, because what happens if we assign an object to itself?
Have we considered this case in our code?
So what do you think would happen if we now say, okay, we are assigning a vector to itself? So maybe just vector equals vector. What would happen in this case when we're implementing it like this? So that this and this other vector is the same object.
Maybe I just put it somewhere in the main, so we would have something like our list equals the list itself, which is of course allowed because you can always assign something to itself.
Basically, nothing would happen. The reference just stays the same.
Yeah, so considering the reference that's returned, that's right, nothing happens with this one. But now imagine calling this operator equals function where this and other point to the same object.
Which is, maybe I can also write it a little bit differently. We could also write it as a function. So this would be the same thing. If maybe this is easier to think about. Somebody not? Yeah?
The vector would be filled with junk data because of the new.
Yeah, exactly.
So, yeah, here, when we have the first problem would be that we are directly deleting our local array, and because other is the same object, here again we would also delete this array. So down here, when you are accessing this one, when we are overriding it here with a new one, we would be accessing the newly created one here. So because this here and this here is the same.
So basically the array where the data was is destroyed.
So we're deleting our data here.
And the new one is created with something in it, and then we copy something in this array. But this is always the same thing here. The other array and our array is the same one. And we just lost our data, and we just initialized the new array with the content that's already written in the new array, which is some rubbish.
So how could we fix this? Well, it's easy. We could just check if this is unequal to the address of the other vector we're passing here, and only do this whole copying stuff if this is the case. So if this and the other is the same object, they have the same address, and therefore we don't need to copy anything because it's already the same, and therefore we just return this.
Okay. So maybe let's also try it out, what you did here. So maybe we now say we have a list which is initialized to 0, and we set the first value to 2, print the list. Then we create another list of the same size, and we say list 2 at position 0 is 1. And then we say the list is the list 2, and print the list again. Then we should see that the first element should now have the value 1 instead of 2, and give it a try. And yeah, it works. So we have first the list where the first element has the value 2, and after we assigned it with the list 2 where the first element is 1, we have the 1 at the very first position. So this operator works. So just to remember this also, just to summarize now this thing, if you implement one of those three, of copy constructor, copy assignment operator, or destructor, then in your class somewhere you do something which might be important that it is considered always. For example, allocating memory and deallocating memory. And if you need to implement one of those three functions, constructor, destructor, then you need to consider all three of them. And you need to either implement them explicitly if you would like to use them, or you can also delete them. So if you say, okay, I need to free memory in the destructor, you can just delete the copy constructor and delete the copy assignment operator if you don't need them, and this is fine. Or you say, okay, I need to copy something, then you implement the copy constructor as well, but delete the copy assignment operator. Because, as we've seen before, these are generated on default. So they exist if you do not delete them, and then you maybe use them at some point, or someone else who uses your code uses them, and then you get some problems in your program because either the memory is corrupted or you free something twice, whatever. So if one of them is implemented, all of them must be implemented. Okay, yeah. That's so far it with the assignment operator. Other question regarding the assignment operator?
Yeah. So maybe just because you always said if you need a destructor, you need to implement the copy constructor. Now you also need to implement the assignment operator.
Then we also grade this at your assignment, so please consider that. Okay, this was now maybe a bit more difficult part. Now I think we have something a bit easier. Now we want to consider these lists or these vectors really as a mathematical thing. So now maybe I create a vector v1 of size 2. So it's a two-dimensional vector as you think about it in math. And then we also have a second vector of the same dimension, of course. And maybe, I don't know, it has these two values here. And if we are now in math, it would be really nice if we could add them. So if we could write something like vector v3 is vector v1 plus vector v2, some addition. And then we print this v3, and it should have then the values 1 and 2, so 3 and 2. Yeah, so it's up to us now that we implement the addition here. And we will write this operator directly in the class. How does it look? We have a vector as the return value. Then we need to write the operator. It's operator plus. And we get a const vector reference as well. What are these parameters? We call the addition on v1. And that's why we write it into the class, this operator, because v1 is the object where the operator is called on. So this is not explicitly here as a parameter because that's the object where this function is called on. The other is then the v2, the right-hand side of the addition. And an addition, of course, returns some value, which is again a vector. And this vector will be used then to initialize the vector v3. And that's why we have here the vector as a return value, the result, and other is the right-hand side of the addition, and the function is called on the left-hand side of the addition. Now we implement this in the CPP. So first we need to initialize a new. Okay, maybe a nice thing would be that we check if the lengths of the both are the same. Otherwise, we could not add them in the mathematical sense. So if they are not the same, we could throw some, I don't know, invalid argument that this does not work. And now we are sure that both have the same length. So we can initialize a new vector v of size length, and then we iterate over the vector, and v at the position I equals our current vector, so array at position I plus other dot array at position I. And then we can return the vector. And why does it not
We
allow
have
me?
a typo.
Length. Okay. Okay. And now this plus operator is implemented, and let's check whether it actually works. And yeah, when we think about the first and the second one, adding the first component gives us 3, and adding the second component, which is 0 by default, plus 2 equals 2 then. So this is then really the correct result. And we really have implemented now our first operator in the classical sense. But we can do much more with that. So you have also prepared something.
What would be especially cool if you could just index into our vector like that. So maybe we could just access the first element with these square brackets like we're used to from other programming languages or C arrays basically. And we can do this. We can also overload this operator. So we want to return a reference to the element. Then just say operator, the operator we want to overload. And then here we want the index, which our vector is accessed. So again, here the left-hand side is the this, and more or less the right-hand side, which is the index with the square bracket operator, is the argument. Another cool thing we can do here now is that unlike with the standard vector, we can now just call at this index. And the nice benefit here is now that we can access and index into our vector while still having bounce checks with these square brackets.
So also this exception is thrown that we have implemented in
because add here throws an exception if it's out of bounds, so we can never get any memory errors, and this now also applies to this brackets operator. And we could try that. I'll comment out this print here, run it, and we can see that at the free vector, the 0th element is 3, which I think was the correct one. Maybe I'd comment it back in. Yeah, 3. So that's the correct one. But we could do something even cooler, which is because maybe if you already programmed Python or did VSB with us, you know that in Python you can access with -1 the last element of a vector or like a list. And so you can basically index from the end of the vector, and this would look like this. So with -1 we access the last element, -2 the previous one, -3, and so forth up until minus length. And we could also implement this here, maybe just with the square brackets for now. So if our index is smaller than 0, that's why I chose integer, because I also want to support negative numbers. And the index need to be greater or equal to the negative length. Why greater or equal? Because we more or less start at 1 here. So this vector has 5 elements, and -5 would be the first one. Okay, and then we can just say that the index is the length plus the index. So if the length is 5, and we say, okay, we want to access the vector at the position -1, then we get 4, and 4 is the index of the last element. And now if we want to access, say, okay, we want to access it at -5, this would be 5 minus 5 is 0, and we have the first element. So this should work like that. And we could also try that instead of accessing the 0th element, we are accessing the last one. Let's run it, and this also works. So accessing at the position -1 now gives us the last element of our vector.
I think that's really cool that you can do that.
So really with these operators, you could do anything you could imagine, any custom logic.
Now a bit bothering that we always need to use this print function here to print a vector, which we have implemented here up in the main, which just iterates over the vector and prints all the elements. It would be nice if we could do something like writing cout and then putting the vector there directly. So we don't need this, I think. So just writing cout and the vector, as we can do this with strings, with integers, and so on. And also for this, it's possible to override an operator, which is then this smaller operator for the output. Okay, now we have an interesting observation here. If we do this plus operator, then on the left-hand side, there is an object of our class. If we have the assignment operator, on the left-hand side, we have an object of our class. But for the output operator now, on the left-hand side, there is this cout. So we basically needed to write this function or this operator in the class of the outstream, because the left-hand side is the outstream and not our class, which we cannot do. But we can also implement operators as functions that are not contained directly in a class, and we will see this now. I will write them also in the HPB, but now below the class definition, so we're outside of the vector. And I will just write it first and then explain what the operands are. Is it now correct, in the correct order?
No, you have to switch it, because on the left-hand side, there's the O stream.
Yes, you are right. That's why we do it. Okay, that's how it looks, the operator. And as you said correctly, on the left-hand side, we have cout. And also in the parameter, we write now the outstream on the left-hand side. On the right-hand side, we have this v3, which is our vector. And the return value should be again an OStream object, because we should be able, after appending our vector here, to continue writing this operator and continue with a vector, with a string, or with the endline sign. And that's why we return the OStream that we can append to the OStream afterwards again. Okay, what do we do here? I would say we, not in the cout, but in the OStream, in this object here, we need to put first, I don't know, maybe some bracket that we indicate that's a vector. Then we iterate over the vector, vector.getLength. And then we put into the outstream as well the element of the vector. Okay, now I can use your fancy operator. And maybe some placeholder and some closing bracket here. Okay. Why does it indicate me that's not working here? Maybe I should use an integer here, right?
Yeah, okay.
Or maybe we will see whether there's a compilation error then. But we iterate over it, put all the objects in the outstream, close it, and then we return this outstream object. And afterwards, in this outstream object, everything on the right-hand side will also be appended, like the end line here. So maybe compile it and see what I did wrong. Okay. Your out operator is not constant. But I can make it const, right?
Yes.
Because we have here a const vector, and we can only call functions that are marked as constant on this object, and for that reason this is not possible. But I can of course mark the operator as constant, and probably here as well, and now it should work. Okay. Oh, I have implemented everything in the HPP, so we just fix this. Switch over to the CPP. That's why you define the functions in the CPP and not in the HPP.
Yes. If you see some weird linker errors, most often it's because you did something in a HPP which you shouldn't have done there.
So try number 10.
The semicolon.
Okay, the semicolon is still here. Maybe I write this a bit differently that you can see the operand still. And last time, and now it works.
Yes.
And now we have our cool operator here, which really prints it as a vector and not, we don't need this print function anymore that we have up here.
And the return value of the output stream operator is again for the same reason like we have with the assignment operator, because if we apply this operator here, we have this stdc out as the stream, v3 as this vector, and then we are returning the stream again, which we then can use to output this end line.
Should I rewrite it as a function? We give it one
you could
try.
do that, yeah.
So if we write this operator as a function, it would look something like this. We have the operator, which takes the cout and the v3, and into this, we want to append the end line. So it looks like this. But we have a no stream here.
So that's probably just because of how the operator with OStream and end line is implemented.
But yeah, okay.
For our implementation, the inner part works.
I could do something like this, then it should work probably. Yeah.
Yeah.
So this works then. So really this left side is taken, then we append the v3 and return the outstream again and can append another vector of it.
Yeah, I think you did function chaining last time. That's a very similar concept.
Yeah,
Or
right.
basically the same.
Okay.
Just this time we're not doing it with this.
This time
And with operator.
we nest the functions. Okay.
Okay, then maybe let's implement multiplication with a scalar. So in this case, just with an integer. And also just for fun, let's implement it outside of our class. So you also see that we can do that. We'll return a new vector, and we want to overload the multiplication operator. And maybe for now, let's start on the left-hand side. We take a reference to a vector, and on the right-hand side, we just take an integer. So let's implement it in the CPP file. And maybe just an example in the main, we want to just be able to do something like this. So on the left-hand side, we have our vector, and on the right-hand side, we have our integer. And what we want to do now is similar to the addition. We create a new vector result. Maybe we could even copy it over already. Like this, and then iterate over the length of the vector. And then with our new vector, at this position, we want to multiply this with I, right? And then return the result. Okay. So we can do this here, this here, because here we are calling the copy constructor, so we already have the contents of this other vector in this new result.
Does somebody see a mistake here now?
Did I do something
Yeah,
wrong?
but this can also happen to you all the time. Does somebody see a mistake here? It's very tricky to see. Yeah?
Maybe the vector double point is missing for the operator.
No? No? Yeah, you use the
Oh,
eye all the time. But it's really tricky to see that, and then once you have this problem, then
okay, yeah.
you may be very confused.
Okay, now it actually output the correct info, so we multiplied the vector with 2. But something we might also want to do is we don't always want to multiply from the right, maybe we want to write it like this. So 2 times the V3, and this won't work now, because in math we can just switch the operands with this multiplication here, but in C++, these are 2 different operations. And what we can do now is just overload the operator with the operands reversed, like this. Yeah, maybe I just copy it. And now we don't need to write everything again. We could just do it like this. Because we already, no, that's the wrong way around. Yeah. Because we are already implemented this operator here, which is where the vector is on the left-hand side and the scalar is on the right-hand side. So we can just use this operator here to define it the other way around. Oops. Okay, now let's check. This also compiles and works.
Mm-hmm. Maybe we can also have a look on some other operators which are not arithmetic operators, but some logic operators.
So I think we once had the question how the bool operator works.
Yeah.
And we can start with doing something similar and overwriting the not operator.
Mm-hmm.
So this operator returns a bool. It's just the not. And because this is, you can also make it const. And because this is just a unary operator, we don't need any argument here. And let's implement it here. And what we want to do here now is just check if this is not the null vector. Or no, if it is the null vector. Because we are implementing the not.
If it is the null vector, then it should be true.
Okay, so again, like this, we can iterate over the array again, then check if the array at the ith position does not equal 0. Yeah. Then return false, and here return true.
Yeah, I think this looks right.
Did I switch it?
No, I think it's correct.
Okay.
So you should be correct this way around.
We can check this now. We can do this. And then maybe do this. So we're creating a new vector with the length 10. And because it will be initialized with 0, so this should be the null vector, and this one shouldn't be. Yes, and this also works. So
we have 0 first because it's not the null vector.
Yeah, because v3 should be true because it has any content, and this should be false, and not false is true, so we have the 1 here.
Okay, yeah, so this works.
But what if you want to do something like this? Then we need to implement another operator, namely so we'll get to the explicit part soon. This is the bool operator now. I need the vector here. And what this does is just it lets you cast your type to the bool type.
I think you don't need the explicit here.
Oh, yeah, okay. Oops. And if we implement this now, and we can just do this. Okay, does it compile? Yeah.
Yeah, it does.
Then we see...
Maybe you can format the output a bit better.
Mm-hmm.
And also remove the print from before.
Then we can see we can just use this here now to like a Boolean value. And this now would also work. So we can just cast our vector to a Boolean now, and this function is called.
Mm-hmm. So this is really nice because you can use now this v3, like if you used a pointer to check whether it's not null, that you directly write it into the if or similar things.
Mm-hmm.
Okay, but now there's something strange happening. So we maybe need to discuss this explicit keyword. A keyword would just omit it for a second, so it's now away. And now I take some integer, I don't know, I, and I write v3. So this should not work, right? Because integer and vector, they do not match. How should this work? So VS Code is wrong.
You didn't save?
I didn't save, yeah, okay. Okay, there is some warning, but it compiled. Unused integer. Yeah, okay, I didn't use it. But I can assign now my vector to this integer, which doesn't make too much sense, I think. And the problem is, if you only implement this operator bool, then it's just a conversion to a bool, and a bool can be represented as an integer. So we have now a way to cast this v3 into an integer.
Implicitly.
Without doing this on purpose. It's just happening. And if we do write this explicit keyword, in this case, it does not do the conversion directly, but we really need to specify the conversion. And that's why this line does not compile. But if we cast it like this, or like we will see this in today's lecture, how to cast in C++, then this conversion would happen. But it would prevent us that we can just assign it to an integer, for example. And this is not affected. This is still working no matter if we write explicit or not.
You could also switch the integer with Boolean and it would work. Because now it's more or less explicit, right?
No, it's still implicit.
Oh, okay. Okay, then it only works in the if.
Yeah, it only works in the if.
Okay.
Otherwise, it's always implicit. Yeah?
Does that only work for primitive-based types or for classes?
This operator here. Do you mean?
I think it also works for classes.
So we can guarantee that you can write here anything, any primitive data type, but I'm not completely sure now if it works for other classes as well. We would need to check this, I think.
I looked this up once, but I forgot. I think it works, but I'm not sure.
We can prepare that for the start of next lecture. Yeah, another question?
Oh, okay. This was just a shortcut I used. We implemented the not operator, and to cast now our vector to a Boolean, I just returned the opposite of our not operator. So maybe if I write it like this. Okay, so more or less like this. So we're calling the not operator and then negating the output.
Of course, you could also just iterate over the array and do the true and false here in the other way around, but it's just like reusing code that we have already written. Any further questions regarding the operator overloading? Because otherwise we would then start with the iterators.
Yeah.
Start at least.
Okay, iterators. So what is our motivation? Well, we want to be able to iterate over our own vector like we are doing with SCD vector or any C array. So with this for each loop. And we'll see now what we need. Let's first start with the for each loop in a C array. This works because we can just create a C-style array here and then use this for each loop to iterate over each element. I can test this.
If it's working. Or not. Yeah, but I think you can trust that this code works.
Okay, and maybe to help you understand this whole topic, let's rewrite it how we would do it with pointers. So we'll create this integer pointer here and call it iter, set it to the first element of the array, so this points here right now, and then we are iterating as long as iter is not equal to the array plus 5. Y plus 5, so this would be plus 0, plus 1, plus 2, plus 3, plus 4, plus 5 would come next. So we still want to have this last element in the iterator, but then afterwards we want to stop. Then we increment it and print the current element by dereferencing this pointer.
So this plus 5 is basically just the length of the array.
Yeah, and it points basically to the integer after the array.
Mm-hmm. Now let's see how this looks like with the vector. Also, here we have seen the for each loop, and probably all of you have already used it in some way. And it's the same syntax as for the C array. Now the question is, do we also have a similar solution with the pointer in the C array? Do we have this now for the standard vector? And the answer is yes and no. Let's see how does it look like. We have the vector. We have some begin. Okay, begin will be probably the first element, and iter will be a pointer to the first element. And then we iterate until we reach the end of the array. So end will probably be this array plus 5 in the example before, or the element which would be after the 5. And then we always increment this pointer or whatever it is, and we can output it. And yeah, if I could execute the code now, you would see that this works. And yeah, it's basically the same concept, but iter is not a pointer, but it's something different. And yeah, let's see what this is. So what is an iterator? So it is a generalization of a pointer. And yeah, it allows us then to iterate over a container. Container is a vector, a map, or all those data types that are predefined in C++. And it behaves very similar to a pointer. And such an iterator needs to implement 3 things. A star operator, not the star operator we've seen before, which is the multiplication, but the dereference operator, similar to a pointer, because a pointer, we want to dereference a pointer. Now with an abstraction of a pointer, we want to dereference the iterator. Then we need some plus operator that we can iterate through the array, that we can always increase the address of the pointer or increase the iterator, the position where we are in the array. And we need some kind of comparison operator, because we need to check whether we have reached the end of the array, similar to the pointer. If we reached array plus 5, then we need to stop. And also the same here. How to obtain an iterator then? So we need these begin and end methods that we have seen before in the vector example. And the begin method returns an iterator to the first element. So C array, pointer to the array, and in the vector, an iterator to the first element. And the end method of the vector returns an iterator to the position after the last element in the vector, which would be similar to the pointer plus length in the C style case. Yeah, and that's the way how we obtain an iterator. And now I think it would be a good thing that we also implement one ourselves.
Okay, so what we are going to do, well, first we need to define some iterator. And in our case, is this just a separate class vector iterator, which stores the position where we are in the array, and we implement the required operators. And then our vector needs the begin and the end method, which both return vector iterators to the correct position. So begin to the first one and end to the one after the last element. So let's look at this, maybe just up here.
Do we just continue in our example from before?
I'll create this class vector iterator. And then as private methods, we want the position. And also a reference to the vector we are iterating over. And then, which operators do we need to override? Let's first implement the constructor. So we take the position, a reference to the vector. I don't know why I named it like this, but okay.
The underscores in the bracket.
No, I accidentally named.
Oh, you
them
named
like
them like this. Okay.
Yeah.
I'm sorry.
Okay, and what operators do we need?
Yeah, maybe if you have already written the constructor, maybe you can also write the begin and the end method of the vector.
So we need the begin, which returns our vector iterator. And we want this method to just return the start of our vector, or an iterator which represents the start of our vector. So we are returning vector iterator like this. And then we have first the position and then the vector. So the position would be 0 and the vector would be this, so the current vector. And then we also need end. And here the position would be the length, because this is the index after the last element. The last element is length -1, and length is the position after that, and this. Yes, and here we can omit the class name, because that's clear with the return type.
Okay, so we have the begin, the end, we have the iterator, and now we need to write these operators that we have seen before. So what is the first that I want to do? The plus operator. Okay, plus operator is always a bit, okay, we do it like this. So we have vector iterator, operator plus. So the plus operator does not take arguments, at least in our case.
You need the reference as a return value.
Oh, I need the reference here. And what does the plus operator in the pointer? It just updates the address. So in our iterator, it would not make sense to increase the position. So we just maybe write it like this, increase the position, and afterwards we return a reference to ourselves. Because if you consider this plus operator, we could of course write something like integer I equals the increased value of position, and that's why we need to write the plus operator this way. So plus operator, we have it. Then we said we need the comparison operator, or the not equal operator. So this should return a Boolean. It takes a vector iterator. It's the operator unequal, and it takes a vector iterator. And I think I need to implement this now into Do I need it? No, I don't
not
need
with
it.
this one.
So I can do it directly here. Okay, when are they the same? They are the same.
Not the same.
When are they not the same? If the position is unequal to other.position. Yeah, so we can just return this, right?
The underscore with other.
Here,
Yes.
okay. So if the positions are not equal, then we return that they are not the same. We could, of course, consider the case that the vectors are completely different here, so we could check the addresses here. But yeah, we'll just leave this now. We don't have that much time.
Okay.
And there's a third operator, right?
So we already have now the begin and the end method, which return this vector iterator, which already behaves pretty similar to a pointer. We can increment it and we can compare it, but one of the most important things is missing, so we also need to be able to dereference it. And so this will return an integer reference if we dereference it like that. And now I can't implement it in the header file just because we have two classes in the same file, and then you get into some trouble. So I'll implement it in the CPP file. And what we need to do here is access this vector here and return the correct element. And the correct element is the one at the current position. So we can now get this vector iterator from our vector, increase it to advance through this vector by incrementing the position, and then also dereference this iterator to get the element at this position of the vector.
So we are prepared that we write now our for each loop,
Yes.
right? Okay, so maybe we do it first in the more difficult way that we have seen before, here with the vector, where we call the begin and the end function explicitly. So now do it for our vector. So we can use v3. So we said, okay, we have, usually you don't write the iterator because it's then clear from the context. Iterator equals v3.begin. Okay, we have implemented this. We want to iterate until we reach v3.end. And we always want to increase our iterator. And now this is not working because we implemented the operator plus plus with the plus plus on the left side. So we need to write those on the left side. And now maybe we could just print, so dereference our iterator, and hopefully this returns us the elements in our vector. Okay, then let's see whether this works, and it does not work. No matching constructor for vector iterator. 51.
How did I define the constructor? I think I swapped
Length and this, and you have also here.
Oh no, okay.
Okay, we have here unknown type name. Okay. You are using the vector here in the vector iterator, but the definition of the vector is somewhere here. So we need a forward declaration here.
Yes, and we also can define the vector iterator after the vector, because the vector needs the vector iterator to return it the begin and the end methods. So yeah, we can have this problem because we're writing it in the same file.
Yeah,
Okay.
Now it worked. So we fixed it. And okay, what did we do? We printed the v3, and this v3 was 3, 2, and now we print the 3 and the 2. So iterating in this manner now works. So yeah, does it also work with a for each loop now in the class?
So this was the whole point, because this is even longer than just iterating with an index. So let's try our for each loop. Now we iterate over each element in v3. And we also don't need this one. And yes, now this one also works. So C++ now automatically, using this syntax, uses the iterator we implemented here to iterate over our array, and it's giving us each element.
Okay, so begin, end, operator plus plus, some comparison operator, and the dereferencing, and now we have implemented our own for each loop.
Yes, but there's way more to this to iterate this.
Yeah. Was there some question? Okay, I don't think so.
Yes?
By implementing these three operators, the plus plus and so on, it's an iterator. But how exactly, in this for each loop, does C++, the compiler, know that the corresponding iterator to vector is vector iterator?
Okay, so the question was, how does the compiler know that the corresponding iterator to vector is the vector iterator? It knows this because we implemented the begin and end method. So like we did before in the for loop, we are calling v3.begin to get our first iterator, and then v3.end to get the iterator where we should stop. So yeah.
Yeah, and everything else is then implemented directly in the vector iterator.
Yes. So an iterator is just something which overloads its operators, and you can iterate over everything which has a begin and an end method which returns such an iterator.
Yeah.
Okay. Then
yeah, we have to skip some part here.
So we are here.
More on iterators. So you can use them, as I said in the beginning, for almost all standard containers. So we've seen it for the vector, so for the built-in vector in the example before, but you can also use it for a map. And if somebody is really attentive in the class, I think we talked about the find method in the map. This also works with iterators. And the important thing is, no matter which data type, which container we're using, no matter whether it's a vector or a map, you always have these iterators and they always behave the same. So you really have some abstraction of your container that you can use always in a similar way. And I think you shouldn't say this, but now I talk about your slide already, but you can use then functions that can work with different containers and do some algorithm on them. And it doesn't matter if this is a vector or a map, it always does the same thing just because we have iterators.
So if you implement a function which works with iterators, we will see that I think next time or after that, then this function can work with any container that supports iterators, and that's almost all of them.
Yeah. And now we implemented an iterator which starts at the beginning and goes until the end. There are also other types of them, for example, which is not such a large modification, but you can also have a constant iterator where you cannot change the elements then. And also reverse iterators that start from the end and go to the beginning. So increasing the iterator means going backwards in the array. Okay, and what is the next time? I already said a bit about it.
So I think we talked about all of that. So we'll just learn about more ways to use iterators, and this then becomes really useful, especially because C++ already provides us with algorithms that we can apply to iterators, and because any container has such method that we can get an iterator from it, we can use it with all containers.
And using algorithms means less code to write on ourselves because it's already there. Okay, I think that was it for today. Do you have any questions left?
For the assignment, if we have very simple line of code, for example, getters or setters, can we include those in the HPP file, or should we always include them in the CPP file?
So if you have in your assignment very short functions like a get or a setter, you can write them directly into the HPP file. This is okay, but if there's more complex logic and it's more than one line, please put it into the CPP file.
Yes, the more you write in the header file, the more likely it is to run into problems like we have just now, where it just doesn't compile. Okay.
I think then that's it. When do we start with the lecture, David? 25. At 25, so 8 minutes break. And yeah, have a nice evening.